Okay, for homework, you guys are doing 25, 27, 29, 31. I'm going to go over problem number 26, and as I mentioned, we're going to do it both ways. So first I'll do it the way that's going to produce a function, and second I'll do it the way that's going to produce a value. And we start with our basic formula. F prime of x, which is the derivative, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And when I substitute, I'm going to get 2 x plus h quantity squared plus 2 times x plus h plus 1. That's my f of x plus h. And then minus f of x, which is the original function. And I'm going to take care of the negative sign or the minus sign at the very beginning. And so we have negative x squared minus 2x minus 1. And that's the negative f of x. Something like that. Okay? So now we're ready to expand that out and work on the problem. So we have limit as h approaches 0 of x squared plus 2xh plus h squared plus 2x plus 2h plus 1, and then minus x squared minus 2x minus 1, and all over h. So all we need to do next, again, if we did everything correctly, anything that doesn't have an h in it should be able to either zero out, should be able to zero out here. So let's see. The x squares go away. Next, let's see, we have 2x and negative 2x, and we have 1 and negative 1. And when we rewrite, we're going to get limit as h approaches 0 of 2xh plus h squared plus 2h over h. And factoring out an h, I would get h times the quantity 2x plus h plus 2 all over h. The h's cancel. And I'm left with the limit as h approaches 0 I have limit as h approaches 0 of 2x plus h plus 2. When I plug in h equals 0, I get 2x plus 2. And at this point, I plug in my original point, which was x is negative 3. I don't need the y here. Again, at the point negative 3 comma 4, I have f prime of x is 2 times negative 3 plus 2, which is negative 4. All right, so that's the first way that we would have gone about doing this problem. And I'm going to give you a second. You can pause at any point if you want to copy that down or study it. And I will go on to do this the second way, where I plug in my x and y values at the very beginning. Okay, in this method I'm starting again with the same basic formula, only my first step will be to plug in my x and y values. Remember that x is negative 3 and y, which is f of x, is 4. And so we're left with f of negative 3 plus h minus 4. Now you could have plugged those directly into the original function, but we've taken an extra step here. So we want the limit as h goes to 0 of negative 3 plus h squared plus 2 times negative 3 plus h plus 1. And then that's going to be minus 4 and all over h. When I expand out the parentheses and the exponents, I'm going to get, remember that negative 3 squared is positive 9. So negative 3 plus h quantity squared is 9 minus 6h plus h squared. Then I'm going to have 2 minus 3 times negative 3, which is negative 6 plus 2h. And then at the end, I'm going to have 1 minus 4, which is negative 3. Again, all over h. When I simplify all those constants, I have 9 minus 6 minus 3, which is just 0. And everything else has an h. When I factor out an h, I'm going to get negative 6h, or negative 6 plus h plus 2. Now I could have added the negative 6h and the plus 2h to get a negative 4h at the beginning there, but it's still going to work out to be the same here. So I get limit as h approaches 0 of negative 4 plus h. When h goes to 0, I'm just left with negative 4. And so that is what we had in the original problem, or the first way that we did it. The first way we found the formula, and then we plugged in the negative 3. This way we plugged in the negative 3 and the 4 at the very beginning of the problem. When we worked it out, we ended up with the same exact answer. So these are two different ways of doing the same thing.